Hello and welcome to another video. In this video we're going to be working on water bottles. And in this one you have water bottles that are initially full of water, and you can exchange empty bottles from the market with one full bottle. The operation of drinking a water bottle turns it into empty. Given two integers, num bottles and num exchange, return the minimum number of water bottles you can drink, or maximum. So let's walk through the examples. So in this example, you're going to drink these first 9. So you have 9. And then you have 9 empty ones, and you can exchange those for 3 full ones because it's a 3-to-1 exchange. So now you drink 12, then you have 3 empty ones. You can exchange those for 1 more full one, and then you drink it, so you have 13 total. And then in the second example, the exchange rate is 4-to-1, and you have 15 water bottles, so you can drink those 15. Then you can exchange those 15 for 3, and you have a couple left over. Then you drink those 3. And then you can exchange, so then you have 6 total empty ones, and you can exchange those for 1, and then you have 2 left over, and then once you drink that one, you have this. So total, you drink 15, 18, 19. So the main idea here is our stopping point is when we don't have enough empty bottles to exchange into a full one. So the idea is we can just have bottles, we can drink them, we can turn them into empty bottles, and we can say, like, do we have enough empty bottles to do anything? If we don't, we're done. If we do, let's try to do something. So let's walk through this example and with some variables. So we have a couple things. Num bottles, 15. Then the exchange rate is 4, and then we're going to keep track of also the empty bottles we have. And I'll just say we have 0. Then the other variable we'll have is the result. And make that 0. So let's make all these bigger. Okay. So basically, in the beginning, we can drink our 15 bottles. And then how many empty bottles do we have? Well, we're going to have 15 then, right? And we're going to have 0 bottles. So now we have to check for these 15 bottles. The conversion rate's 4-to-1. So how many of these can we convert to regular bottles? And then how many empties do we have left over? So if we have 4-to-1, we can convert 12 into 3 full bottles, and then we'll have 3 left over, right? Like in this picture. So then we can drink 3 more, and our result is 18. Then when we drink those 3, we have 0, and we have 3 more empty, so we have 6 total. Then once again, we check, can we do anything with our empty bottles? And yeah, we can. We have enough to do a conversion. So we can convert 4 into a bottle here. Then we'll have 2 empty. Then we'll drink this guy. And that will give us another empty. And then we can't do anything. So the basic idea is you take your water bottles, you add them to the result, then you convert them all to empty bottles. And then from the empty bottles, you figure out, like, can I convert some of those empty bottles into full bottles? If I can, let me subtract from there and keep an empty variable. And as soon as I don't have enough empty bottles to even get one regular bottle, then I'm basically done. So that's kind of the thing we need to do. So we're going to have a water bottles variable, an empty bottles variable, and a result variable. And we can just loop until so the way we're going to do it is we're going to say, if we can't convert the empty into full, then we're done. And by that, we're just going to check while we have full water bottles, let's do stuff. So if we have full water bottles, let's drink them, let's convert to empty. And then once we can't convert empty to full, then this will be 0, and then we'll break. And then we can do this. So let's code that. So we need a empty bottles. And let's actually rename this to make it a little bit clearer. So we'll say this is full bottles. And this is, let's call it empty to full ratio or something. Okay, so it's a little bit more descriptive now. So the empty bottles will start out as 0, and the result will be 0. So we're going to say, while we have full bottles, let's keep doing stuff. So what can we do? Well, we can drink all of our full bottles and add them to our result. And also, all of those full bottles now become empty. So we can say empty plus equals whatever it had before, but now these ones as well. So now we have to calculate how many full bottles can we have now? Like, we only have empty bottles, so how many full bottles can we get out of those empty bottles? Well, the full bottles, it's just going to be the empty bottles over the exchange rate. So for example, if, you know, we have 20 empty bottles and the exchange rate's 5, then we'll get 4 full bottles and so on. And then the empty bottles is the remainder. So I guess this is empty bottles. Right, so we exchange some of them and then we have some remainder left, possibly. And so that's the remainder. So this is empty bottles, mod, empty to full. So for example, if we have 15 bottles and the exchange rate's 4-to-1, we'll do 15 mod 4, which will give us 3. So we'll have 3 empty left over. And we basically just keep doing this until we have no more full bottles. Eventually, we're going to get to a case where we don't have enough empty bottles to convert and we still have no full bottles. Yeah, because this will basically end up being 0, right? Like if you have 3 empty bottles, but the exchange rate's 4-to-1, this will be 0. Okay, and then we can just return the result. All right. Interesting. Not enough Java solutions. Okay. So time-wise, basically, what are we doing here? So we're dividing the full bottles by the exchange rate every time, I think. Like technically you're adding full bottles to the empty bottles. But you're basically taking your number and you're like dividing it by 3, or not by 3, by the full, by the exchange rate every time. So I think this is something like full bottles. This is like log base. So like normally you have like a log where it's like log base 2. Here it's log base empty bottles, or empty to full ratio. Because we're just taking the full bottles and dividing it roughly. We're just taking the full bottles and dividing it by the ratio every time. So it's something like that, some kind of logarithmic function, because you're basically just dividing over and over and over and over. And then space. So I'm curious what this one says. It's going to be like, this might not be exactly it, but it's something like this. It's like a logarithmic function, because we're not like, we can do a simulation where we go 1 bottle at a time, and that would be a lot slower. Or because we're not going 1 bottle at a time, we're just taking them and converting right away. I think it's going to be logarithmic. So let's see what it says. Yeah, so log and log full bottle, something like that. I think for like a coding interview thing, you can probably just say this. But obviously, if the ratio is bigger, it'll be faster, but it won't be like significantly faster, I guess. It'll still be like logarithmic. And then this will just be a 1. Yeah. Okay, so yeah, that's going to be all for this one. Pretty easy one. Hopefully it made sense. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.